Hello everyone. Today I'll be discussing P3 from the February March 2026 session. As you all know, I have already solved the paper and I've color coded each solution so it's easier for you to follow, and I'm going to upload this PDF file on the comment section of this video. So let's begin. Before I do, I'd like to refresh your memory about what Cambridge recommends when you round your answer. So Cambridge recommends that you round it to 3 significant figures, or if it's angles in degrees, then you round it to 1 decimal place, unless the question specifies a different level of accuracy. Like during in numerical solutions questions, the Cambridge is going to give you a different level of accuracy. You have to maintain that, otherwise you're going to lose marks. And for intermediate steps, make sure you write intermediate answers to a higher level of accuracy than the one specified in the question. So let's begin. Question number 1. I believe this is about indices. So it says solve the equation 4 times 2 to the power x plus 2 minus 5 times 2 to the power 2 minus 6 equals 3. And you have to round it to significant figures. So all intermediate steps, you round it to 4 or more significant figures. So as you know from the rules of indices, if there is addition in the power, you can write it as a product of two indices with the same base. So 2 to the power x plus 2 then becomes 2 to the power x times 2 to the power 2, and 2 to the power 2 minus x becomes 2 to the power 2 divided by 2 to the power x. And then you can take the 2 to the power x as a different variable. I chose y. So then this becomes 4 times y times 4, which is 16y, and this becomes minus 5 times 4 by y equals 3. So if I bring everything to one side, I get 16y minus 2 by y minus 3 equals 0. I'm going to multiply the entire thing with y so that I can eliminate the fraction. So then the equation turns into a quadratic equation, 16y squared minus 3y minus 20. So interestingly, this you cannot use basic factorization here, so I'm going to use the quadratic formula. The quadratic formula is provided in the formula booklet. So the formula is minus b times plus minus root over b square minus 4ac divided by 2a, right? So a here is 16, b is minus 3, and c is minus 20. So if you use that, you get two values of y. Notice that I have rounded it to 1, 2, 3, 4, 5 significant figures. Now I know that this is y is equal to 2 to the power x, so I could say that 2 to the power x is equal to 1.2157, right? And then I can take log on both sides, right? Or I can turn this in from exponential form into logarithmic form. So you get an answer for this. Since the value of this indices is negative, you will not be able to find any solution for this. So you will only get one solution. And if you round it to three significant figures, you get 0.282. Moving on to question number 2. Oh, this is about complex numbers, right? So question says you have a complex number z that satisfies these two conditions. Modulus of z is equal to 9, and the argument of z is between half pi and pi, right? So this is a familiar type of equation. So if you take modulus of a complex number and it's equal to a constant real number, then you know that this is an equation of a circle with a radius of 9, and the center would be equal to 0, 0. And it says argument has to be between pi by 2 and pi. These are obviously given in radians, so if you convert them into degrees, you have 90 degrees to 180 degrees. Positive 90 degrees and positive 180 degrees, that is. So if you want to draw this on the Argand diagram, I'm going to draw a circle, right? And the circle will be, since it says between 90 and 180 degrees, the circle will be in the second quadrant. So the center is 0, 0 and the radius is 9, right? So the maximum value would be 9i, and the leftmost point would be minus 9, 0. So that's it. This was a very easy question. So part B is a bit tricky. It says on the same diagram, sketch the locus of the points representing the conjugate of z plus 3. So let's see. You have this point, right? This point has a coordinate. Let's say call this point u. So this would have a coordinate. The real part of this point would be 0, right? 0, and the imaginary part is 9i, right? So that's u. So if I were to find the conjugate of that, use asterisk, that would be equal to, the real part remains as it is, and the imaginary part, you take the opposite sign, right? So it would become 0 minus 9i, right? And then you're adding 3 to it, right? So if you add 3 to it, it becomes 3 minus 9i. Similarly, let's say I have this other point, right? This is what? Let's call this v. This was equal to minus 9 plus 0i, because it's on the real axis, so the imaginary value would be 0. So if I take the conjugate of that, it's going to be equal to minus 9 minus 0i, and if I add 3 to it, I get 9 minus 9 plus 3 is minus 6, right? So you have minus 6, right? Minus 6, and this point becomes 3 minus 9i, which is this 3 minus 9i. Now, another way of looking at this is when you take the conjugate of any conjugate of any complex number, you are actually reflecting that complex number on the real axis. So originally the diagram was like this. So if you deflect it on the x-axis, you get something like this, right? You get the entire thing on the third quadrant, and then after you translate it by 3 units, it moves 3 units to the right. So this is your answer for part B. So the diagram that I've drawn with the red ink is part A. The diagram that I've drawn with the green ink is part B. Moving to the next question, then it says find the exact value of integration of 3 sine x sine 2x between 1/4 of pi and 1/3 of pi, right? So now what you can do is, if you use the formula booklet, you'll see that sine 2x, or rather it's sine 2, I believe, sine 2a equals 2 sine a cos a, right? So sine 2x would be 2 sine x cos x. So if you simplify that, you get 6 sine squared x cos x. So there is an easy way of solving it. That is, you can use substitution here, but it would be lengthier. So another way would be, if let's say I consider this as my function. So if you have the derivative of that, if you multiply, if in the integral, if you have the derivative of the function multiplied to it, then you can just integrate the power. So the rule is something like this, right? So if you have a function, right, and the derivative of that function, right, is multiplied with that function. So when you integrate that power, so what I'm going to do is, if I were to integrate this, I could have it in it like this. That's the easier way of doing it. However, I use the linear method, so that's n by n plus 1, right? Let me just move it up a bit. So you could have done it easily. So that would have been, since you have, if I say that sine squared x is my function, and so if sine x is my function, right, then what's the derivative of sine x? That's cos x. So it's there, right? So I could just integrate this. So it would be sine cubed 6 sine cubed x divided by 3. Easy. What I've done instead is I have used substitution here. So obviously the question did not mention what you will have to take, what you have to substitute. Right? So I'm going to take sine x as u, and then if you differentiate that, you get cos x. So du would be equal to cos x dx. This portion then becomes dx. This is 6u squared. I'm going to replace the limits as well, right? So pi by 3 becomes root 3 by 2, and pi by 4 becomes root 2 by 2. So then this becomes very simple. It becomes 6u cubed by 3, which is 2u cubed, right? So, and then if you put in the limits, you get your answer. And I believe it says give your answer in exact, I mean third form, right? So you cannot round it here. So after simplification, cube root of square root of 3 by 2, root 3 by 2, if you cube it, you get 3 root 3 by 8. So I can cancel 2 ones are and 2 fours are, right? Here it's 2 and 2 for, if you want to cancel with 8 to get 2 left. So this is going to be your answer. Moving to the next question, it says the coefficient of x cubed in the expansion of this, right? So you can use this formula that's given in the second page, right? We're going to use this expansion formula, right? So 1 plus nx plus n into n minus 1 by 2 factorial x squared plus n into n minus 1 into n minus 2 by 3 factorial x cubed and so on. So it says the coefficient of x cubed, right? So I'll have to just focus on this. So n here is 2 by 5. So I don't have to look for the first term, second term, or the third term. I can directly move on to the fourth term, right? So it's n into n minus 1 times n minus 2 divided by 3 factorial times this cubed, right? But since I'm looking for the coefficient, I did not write the x. It's just minus a. So now when you expand this with your calculator, you'll get, if you simplify this with your calculator, you get minus 8 by 125, and this minus 8, sorry, this will give just 8 by 125, and you have a minus a cubed. So that simplifies to just minus 8 by 125 a cubed. That's equal to 1. So if you make a cube the subject, now you have minus 125 by 8. So a would be equal to minus 5 by 2. Moving to the next question, it says, hence find the coefficient of x to the power 4 in this expansion. So I have 2x plus 1, and obviously it's this, right? So how can I get x to the power 4 if I expand this? So if I multiply 2x with the x cubed term, which is 1x cubed, I'll get x to the power 4. And also, if I multiply 1 with the x to the power 4 term, I'll also get x to the power 4. So I have to find that term as well. So that would be, I have x cubed, and then I'm going to take n into n minus 1 times n minus 2 times n minus 3 divided by 4 factorial times. I already know the value of a, which is, sorry, I did not mention the minus here, right? Not that it matters because you have the power is even, right? So 5 by minus 5 by 2x whole to the power 4, right? So if you expand this and simplify, you get minus 13 by 8 x to the power 4. So now what we are going to do is I'm going to multiply this with 2x plus 1, right? So 2x plus 1 times this, there are some terms before preceding these two terms, and there are some terms after that. But we are not focused on that because those, if you multiply that with 2x plus 1, will not give you any term with of x to the power 4. So if I multiply 2x with this, I get 2x to the power 4, and if I multiply 1 with minus 13 by 8 x to the power 4, I also get an x to the power 4 term. So if I simplify that, I get 3 by 8 x to the power 4. So the coefficient of x to the power 4 then would be just 3 by 8. Moving on, so this is question says state the set of values of x for which the expansion in 4b. This would be 4b, right? So for it to be valid, this modulus of minus ax has to be less than 1, or I could say modulus of 5 by 2x. So I could just take the 5 by 2 to the other side. So therefore, I have modulus of x would be less than 2 by 5. This is one way of writing it. If you prefer, you can also write it like this as well, right? Minus 2 by 5, x is between minus 2 by 5 and 2 by 5. They mean the same thing. Moving to the next question, this is about complex numbers again. Okay, so you are given a complex number z, which is 3 plus lambda I divided by lambda plus 2i, where lambda is a real constant. Okay, interesting. It says find the value of lambda for which argument of z equals 1 by 4 pi. So to find the argument, I have to find the real part of this complex number and the imaginary part of this complex number. So what I'm going to do is I'm going to multiply both the numerator and denominator with the conjugate of lambda plus 2i. So the conjugate of lambda plus 2i would be lambda minus 2i. So multiply both numerator and denominator with that. So 3 times lambda is 3 lambda, 3 times minus 2i minus 6i, lambda I times lambda is lambda squared I, and then you have lambda I times minus 2i is minus 2 lambda I squared, right? And you have a plus b and a minus b in the denominator. That simplifies to just a squared minus b squared, right? So after simplification, this will give you a real term. This is the real part of the complex number. This is also the real part, right? So it's 3 lambda plus 2 lambda, which gives you 5 lambda divided by lambda squared plus 4, right? This is the real part, and minus 6i and then plus lambda squared I, right? So this divided by, of course, the denominator, lambda squared plus 4. This gives you the imaginary part. So how do I find the argument is the imaginary part divided by the real part, right? And if you take tan inverse tan of that, you get the angle argument, right? So tan of the argument, which is 1/4 of pi, that's equal to this. So I can cancel out this because this is division. So if you were to flip it, you would have cancelled the lambda square plus 4. So you're left with just lambda square minus 6 divided by 5 lambda. And you know that tan 1/4 of pi is equal to 1. So if you cross multiply, you get a quadratic equation now. So if you factorize it, you get two values of lambda. One of them is 6 and the other one is minus 1, right? So, but the question here says find the value of lambda, right? So you have two values, you have to figure out which one is a valid one and which one is not a valid one, right? So how do I do that? Since I have two values of lambda, let's say, okay, this one would be not applicable, but let's see why that's the case, right? So let's see. If I were to take this, right? If lambda was equal to 6, then my equation, the complex number z then becomes, wait, 3 plus 6i 3 plus 6i divided by, what do I have here? 6 plus 2i, right? 6 plus 2i. So you can use your calculator. Let me get my calculator. So this is 6, right? 3 plus 6i divided by 2, 6 plus 2i, right? Wait, did I do something wrong? 6 3 plus 6i, right? 3 plus 6i. Okay, oh, what, I made a mistake in my bad. I. So you're supposed to get, if you simplify this, you're going to get 3 by 4 plus 3 by 4i. Okay, fine. Now, this seems good because this will be in the first quadrant, right? According to the question, the argument of z is 1/4 of pi. So that's in the first quadrant. So let's try with the other value, right? Yeah, what was the other value? If I were to take z as minus, sorry, lambda is minus 1, z then becomes 3 minus lambda, 3 minus I. So 3 minus I divided by minus 1 plus 2i, right? Minus 1 plus 2i, right? Minus 1 plus 2i. So if you simplify this with a calculator, minus, you get minus 1 minus I. Of course, obviously this is in the third quadrant, right? Since it's in the third quadrant, this doesn't satisfy this condition. So that's why lambda cannot be equal to minus 1. So you only have one value of lambda, that's 6. When the lambda has their value found in 5a, find the exact value. Okay, so I've already found this, right? So if I took lambda as 6, right? You get 3 by 4 plus 3 by 4i. So how do I find the absolute value of this? So it's root over real part squared plus imaginary part. So it's root over 3 by 4 squared plus 3 by 4 squared. So it simplifies to 18 by 16, right? So you can square root 16. You'll get 4. If you square root this, 18, it's 9. 18 is 9 times 2, right? So you square root of 9 is 3 and root over 2 remains as it is. So that's your exact value. You cannot round it because the question asks for the exact value. So it's 3 by 2, 4 root 2. If you want, you can write it as 0.75 root 2. That's also the same thing, right? So this question is from polynomial. So you have a quartic polynomial, right? With two unknown coefficients. So it's 2x to the power 4 plus ax to the power 3 plus bx 4x squared plus bx minus 3, right? And it is given that this is one of the factors. So since it's a quartic polynomial, this will have two quadratic factors. One of the quadratic factors is given, the other is not given, and you are told to find the coefficient. Since I know that the other would be a quadratic this quartic polynomial is going to have another quadratic factor, so I can write it like this. If this is one of the factors that's given in the question, the other factor I say kx squared plus qr plus ux plus r. I could have written ax squared plus bx plus c, but since there is already n b in the question, I did not use that. So if you inspect the polynomial, we will inspect the leading term here, right? So the leading term is 2x to the power 4. I have x squared here, I have px squared here. So how do I, if you multiply them, what value of p would give you 2x to the power 4? That 2x squared, right? So 2x squared times x squared gives you 2x. Now I'm going to compare the constant terms. So you have a constant term of 1 here and a constant term of r here. So 1 times r is supposed to be minus 3. That means r is going to be equal to minus 3. So you have already figured out two of the coefficients of the other factor, quadratic factor. Now I cannot compare this because I do not know the coefficient of x cubed, I do not know the coefficient of x, but I know the coefficient of x squared, right? So I'm going to compare that, and from there I'm going to find the value of q, right? So how can I get x squared? So x squared times minus 3 will give you x squared, x times qx will give you x squared, and 1 times 2x squared will give you x squared, right? So there are three ways you can get x squared. So it's 2x squared plus qx squared and minus 3x squared. So if I compare the coefficients, I don't have to mention the x squared. So here the coefficient of x squared is 4, and you have 2. 4 equals 2 plus q minus 3. So from there you can easily figure out the value of q. Q is 5. So how do I find the value of a and b? Simple. I'm just going to replace q with 5 and I'm just going to multiply them out. So if I simplify that, I get a quartic expression like this. So if I compare this, a would be equal to 7 and b would be equal to 2. You could have used long division, but that's going to be a bit lengthy, so that's why I prefer inspecting the quartic polynomial and then finding the other factor and then using that to find the unknown coefficients. Moving forward, it says hence show that x plus 3 is a factor of this. So I'm going to use the factor theorem here. If p of x is equal to this, if I take p of minus 3, if I get 0, that means x plus 3 is a factor. So I do get 0. So I have found the factor. So I know that x plus 3 is a factor of p of x. Okay, moving on. And another way would have been factorizing this. But I feel like using factor theorem is easier, simpler rather. Moving to the next question. It says by sketching suitable pairs of graphs show that the equation ln x equals cosec half x has exactly one root in the interval 0 to x to pi. Right? So if you sketch this, you'll see that they will intersect at a single point. That means they'll have one solution. So you know what you're expected to know the graph of ln x, you're expected to know the graph of cosec half x. So cosec half x will have a period of 4 pi. Right? So here the cosec x will have the y-axis as an asymptote and it will reach at pi, cosec half pi would become 1. So this is going to be equal to 1. And then ln x, it looks like this. Ln x also has the y-axis as the asymptote. It got the x-axis at 1. And if you take ln pi is going to be more than 1. So that means it will cut somewhere in between. So just by saying that they intersect at a single point. So let me mention it here. The two graphs intersect once, so there is only one, I believe it says root, right? So one root in the given interval. I have to learn how to type faster. It's better to mention this. So moving to the next question, it says verify by calculation that this root lies between 2.6 and 2.9. So what you're going to do is you're going to bring everything to one side of the equation and then you're going to take that as a different function and then you're going to plug in 2.6 and 2.9. So let's say bring everything to one side. Let's say call this f of x. So I'm going to find the value of f of 2.6, f and f of 2.9, right? So f of 2.6 is minus 0.082 and f of 2.9 is 0.057, right? So one of them is positive, the other one is negative. So that means since there is a change in sign, I can say the root lies between 2.6 and 2.9. Moving to the next question, is it says use the iterative formula x n plus 1 equals exponent of cosec half x n to determine the root correct to 3 decimal places. Give the results of each iterations to 5 decimal places. So each iteration you have to give it to 5 decimal places, but the final answer for the root will be to 3 decimal places, right? Okay, it also gives a hint here. Exp of x is an alternative notation for e of x. So you can write e of x as this. So the question does not give you the starting value. So you can take 2.6 as a starting value, you can take 2.9 as a starting value, or you can take the mid value of these two. Either way, you're supposed to get the same answer. So I chose 2.6 as my seeds, x1. So let's say that x1 is 2.6. So I'm going to put 2.6 here. I get 2.82306 to 5 decimal places, right? And then I'm going to put this in here to get x3, and that's 2.75335. Put that here, you get x4, x5. Oh, I've made a mistake here, right? Never mind, I'm going to correct. Actually, let me correct it here, otherwise I'll forget. This is x4, so this would be x5. You have x6, this is x7, right? Oh, what's wrong with me? X7, so this would be x8, this is x9, and this is x10, right? So I have rounded each of these numbers correct to 5 decimal places, right? So you notice that they're all converging. So if finally, since the final answer has to be rounded to 3 decimal places, I'm going to look for the 4th decimal place. When it matches, you can stop, right? So it matches here, and it matches here as well. So I can stop. I could have stopped at x8, but I went further. So if I round this to 3 decimal place, it's 2.767. Moving to the next question, it says that the variables x and y satisfy the differential equation y e to the power 3x dy by dx equals y times x plus 5, right? It is given that y is equal to 0 when x is equal to 0, so this is an initial condition. You could use that to find the arbitrary constant, right? So how do I solve this differential equation? I'm going to separate the variables. I'm going to bring all the terms with y on the left side of the equation, and I'm going to take the variable x to the right side of the equation. So that means if I take the y plus 5, I'm going to bring it here. So it's y divided by y plus 5 dy equals x divided by e to the power 3x, right? Dx. So this is an improper fraction, right? So I've used long division to write this as a mixed number. So then this becomes 1 minus 5 by y plus 5 dy, and I can write this as e to the power minus 3x. So I'll have to use integration by parts for this, right? So for integration by parts, I'm going to take x as u, so u is equal to x, so du by dx would be equal to 1, and I'm going to take this as d by dx. So d by dx is equal to minus 3x, so x would be v would be equal to, there's a minus here, e to the minus 3x divided by minus 3. So the formula for integration by parts is provided in the formula booklet. So using that, you get this, right? So if you integrate 1, you get y minus 5 by y plus 5. If you integrate that, you get minus 5 ln y plus 5. And then it's uv, so x times e to the power minus 3x by 3 minus integration of v du by d. So this times this, 1 times e to the power minus 3x by 3 minus 3. So this, you have already integrated this. Before I integrate, make sure you're careful about the sign. So you have a minus here, you have a minus here, that becomes plus 1 by 3 to the power minus 3x. So if you integrate that, you have to divide plus 1 by 3 divided by minus 3 gives you minus 1 by 9 e to the power minus 3x. And then don't forget about the plus c, right? And using the initial condition of y is equal to 0 and x is equal to 0, if I put those in, y equals 0 and x would also be equal to 0. So this becomes 0, this becomes minus 1 5, this term becomes 0, so I'm left with minus 1 by 9 e to the power 0, which is just minus 1 by 9 plus c. So that means c is equal to 1 by 9 minus 5 ln 5, right? So now the question, let me check again. It does not say to make y the subject or the x the subject. So you can just keep it like this. Y equals y minus 5 ln y plus 5 equals minus 1 by 3x e to the power minus 3x minus 1 by 9 e to the power minus 3x, then c, which is 1 by 9 minus 5 ln 5. However, this is just my personal preference. I don't prefer fractions. So what I did was I multiplied the entire thing by 9b LCM of the denominator. So then you can ignore then the equation will not have any fractions. So if you multiply this with 9, you get 9y minus 5 times 9 is minus 45 ln y plus 5. Multiply this with 9, you get minus 3x e to the power minus 3x. This multiplied by 9 gives you minus e to the power minus 3x. 1 by 9 times 9 is 1, and then this is minus 45 ln 5. This Cambridge would accept, but this is just a personal preference of mine, so you don't have to do this. Moving to the next question. So you have I equals this, right? And you have to use substitution here, right? So the substitution is given x is supposed to be equal to root 3 tan u, right? So you have to show that this integral can be written as this. So since I'm using substitution, x is equal to root over 3 tan u. So if you differentiate this, you get root over 3 sec squared u. So that means dx is root over 3 sec squared u du. So if x is equal to 3, u would then become 1 by 3 pi. If x is equal to 1, u would become 1 by 6 pi. So substituting everything into the equation, I then becomes 3 would become 1 by 3 pi. The 1 would become 1 by 6 pi, and I can write the x as root 3 tan u whole cubed, right? And 3 plus root 3 tan u whole squared times dx was root 3 sec squared u du, right? So if I simplify this, I can write root 3 cubed is 3 root 3 tan cubed u times root 3 sec squared u. Here I have 3 plus 3 tan squared u, right? Interestingly, I can take 3 common from the denominator, and the third would go away because 3 root 3 times 3 would give you 9. So it's 9 times tan cubed, right? Tan cubed u sec squared u du. And if you take the 3 common, you will be able to cancel them, right? So what is 1 plus tan squared u? If you look at the formula booklet, 1 plus tan squared u is actually equal to going to be sec squared u, right? So this, you can write this as sec squared u, right? So interestingly, since we have sec squared u in the numerator and the denominator, you can cancel them out. So then that gives you what the question asks for you to prove. So integration of 3 tan cubed u du from 1/6 pi to 1/3 pi. So we are done with this part. Let's move to the next part. It says hence or otherwise find the exact value of I. Since I've already simplified it to this form, I'm going to go for hence, right? So give your answer in the form. So you have to give your answer in exact form. P, Q, and R would be rational number, which means they have to be fractions. Remember, integers are also fractions, right? So you have something like this: 3 tan cubed u du, right? So I'm going to separate them out. Tan u, I'm going to break the tan cubed u as tan u times tan squared u. And I know that tan squared u is sec squared u minus 1, right? There's a reason why I'm doing this. It will become clear. So now if I multiply them, I get 3 tan u sec squared u minus 3 tan u, right? So I'll have to integrate this. Integration of this is easy, right? 3 tan minus 3 tan u would be minus 3 ln sec u. This is the same as question number 1, right? Where I said, no, sorry, not question number 1, it was question number 3, I believe. So f of n, f to the power n x times f prime x. If you want to integrate that, all you have to do is integrate the power. So I'm going to use that same principle here. Give me a minute. So you have tan u is my function, and the derivative of tan u is x squared u. It's there, right? So I'm going to integrate the power. So you can assume that there's tan, you have tan as a power of 1. So if you integrate the power, it becomes squared. So 3 tan squared u divided by 2, the power. You don't have to worry about this x squared u, it goes away. And this then makes it easier. If you don't prefer that, you could have always taken tan u as, you know, another variable. So then in that case, you would have substitution, given another substitution inside the other substitution. To avoid that, I've done this, and there, it is only 5 marks, so it's not worth the hassle, right? So I'm going to plug in the upper limit first. So tan squared 1 by 3 pi minus 3 by 2 tan squared 1 by 3 pi minus 3 ln sec 1 by 3 pi, and then I'm going to plug in 1 by 6. So tan 1 by 3 pi is just root 3, so tan squared will be just 3, right? Sec 1 by 3 pi is, cos 1 by 3 pi is half, sec 1 by 3 pi would be 2. And then here, 1 by 6 pi, right? That's 1 by root 3. So tan squared 1 by root 3, 1 by 6 pi would be 1 by 3. So you can cancel out the 3's. So you're left with half here, and sec 1 by 6 pi is root, cos 1 by 3, 1 by 6 pi is root 3 by 2. So sec 1 by 3 pi, 1 by 6 pi would be 2 by root 3, right? So you can write it like this. So now if you remove the bracket, you have minus half, and then 9 by 2 minus half would give you 8 by 2, right? Which you can simplify as well, right? So you're just left with 4. And then you have minus 3 ln 2, and you can break this up, right? So it's 3 ln 2 minus 3 ln 3. So that way I can also cancel this and this. So that's very good. It has become very simple. Now the question says PQNR has to be rational. So if you have root 3, it's not rational, right? So what I did was I wrote the root 3 as 3 to the power half. I brought it here, so then it becomes 4 minus 3 by 2 ln 3. 4 is a rational number, minus 3 by 2 is a rational number, 3 is also a rational. Rational number means something that you can express as a fraction. 4 is also a fraction because 4 by 1 is a fraction. So all integers by definition are fractions. So this is going to be your answer for this question. Moving to the next question, you have the variables x and y satisfy the equation y squared equals k times x minus 2 divided by x plus 2, where k is a constant. You have to show that if you differentiate this, you get 2y divided by x squared minus 4. So you will have to use implicit differentiation here, right? So y squared equals this. So if you differentiate y squared, you get 2y dy by dx, right? And for this, you have to use quotient rule. So x plus 2 times differentiation of the numerator, which is just k, minus k times x minus 2 times differentiation of the denominator, which is 1, divided by denominator squared, right? So after, I can remove the bracket now with kx plus 2k minus kx plus 2k again. So the kx, you can cancel them out, right? So you're left with 14 in the numerator, and let's say I take the 2y to the other side, you have this, right? So I can cancel this, and I can write this as 2. So the question says there should be a 2 in the numerator, so we already have a 2, but we need a y here, right? We don't have a y, and you have to have x squared minus 4 in the denominator as well. We don't have that as well. However, there is a y in the denominator. You have to bring it in the numerator. So what I did was, okay, let's keep it like this. So you have y times x plus 2. I can bring the x plus 2, separate it out. X plus 2 whole square, I can write it as 2 separate fractions, right? So 2k divided by y times x plus 2 and 1 by y x plus 2. And if you look at this equation, 1 by x plus 2 is just you take these two on the other side. So k would go in the denominator, x minus 2 would go in the denominator. So you have y squared divided by k times x minus 2, right? Just another way of writing it. So let me just do it here again for convenience. So it's y squared equals, again, k times x minus 2, right? So it's k times x minus 2 divided by x plus 2, right? So if you take this and this to the, if you take the x minus 2 and y, k to the other side, you have y squared divided by k times x minus 2, right? So that's equal to 1 by x plus 2. That's what you have here. So I've replaced this with this, right? So now what happens is you can simplify it. So the k in the numerator denominator they cancel out, the y that goes away. So you're left with 2y in the numerator and x plus 2 times x minus 2 in the denominator. So it simplifies to x squared minus 4. That's what the question told you to show. So you're done with this, right? Remember, this might come in handy in the second part of the question. Now it's given that k is equal to 5. Find the angle between the tangents to the curve when x equals 4, right? So, or x equals 3. So k is equal to 5. Now give your answer in the form a tan inverse b by 2. We're going to look at it later. So I know that k is equal to 5. I know that x is equal to 3. So I also have dy by dx, right? So I'm going to put in k as 5, x is 3 to find the value of y and dy by dx, right? So if x is 3, I need the value of y, right? I don't have that. So what I did was I put this into the original equation, which was this y squared equals k times x minus 2 divided by x plus 2. So I know the value of k, I know the value of x, so y squared then becomes 1. So from there I get two values of y, plus minus 1, right? So I have two tangents, that's what you have here, between the two tangents. So one tangent forms at 3, 1 and the other tangent forms at 3 minus 1, right? So, and both these points I'm going to find the gradients. So when at 3, 1 the gradient is 2 by 5, and at 3 minus 1 the gradient is minus 2 by 5. Interesting, they are the same gradient, just opposite signs. So let's do a sketch of what the lines would look like, right? So since the gradient is positive here, it would be an upward sloping graph, and since the gradient here is negative, it would be a downward sloping graph, but they will have the same steepness, right? So I could say that this is equal to alpha, so this would also be equal to alpha, right? The question says to find the angle between the tangents, right? So that's 2 alpha. So let's try to find the value of alpha. I know that gradient is actually equal to tan alpha here, right? So tan alpha equals 2 by 5. So alpha would be equal to tan inverse 2 by 5. And theta would be just double that. So 2 times tan inverse 2 by 5. So that's your value of theta. So if you compare with what the question told you to do, it says 2 times tan inverse b by c. So where a, b, and c are integers. That's what we got. 2 here, and c is 5. You don't have to mention which one is which. Cambridge would understand. But then again, if you really wanted to, I could have done it. So a equals 2, b also equals 2, and c I believe is 5. Did I get the order correct? Yep. You don't have to mention this, by the way. Moving to the next question, or this is the final question. This is about vectors. The points A and B have position vectors. OA is this, OB is this, related to the origin. Show that the perpendicular distance from A to the line through O and B is 1/3 of root 65, right? So let's draw a diagram. So you have O and B, right? That's a straight line, and you have another point A. It says the perpendicular distance from A through to the line through O and B. So they got to find this length, this dashed length. So this point is at the foot of the perpendicular on the line OB, right? From OA to OB. So what I need to do is, if I could find the coordinate of x, then I could just find the length using the distance formula, right? So let's find the equation of this line, right? The equation of this line would be a passing point. So it passes through O. So I've taken O as my passing point, and the direction would be OB, right? Which is 4, 2, 4, right? This is your equation. Now, since f is on this line, I could say that f is equal to the same thing, right? For a certain value of t, which we do not know yet. So next is, since they are perpendicular, right? So since they are perpendicular, that means the dot product of AF and OB should be equal to 0. So that's what I did here. So from there, I would be easily be able to find the value of t. Once you have the value of t, you know what AF is. Just plug in the value of t. So you get AF, and then you find the magnitude of AF, you get this one. So AF is 4 times 2 4 times 2 by 9 minus 2, then 2 times 2 by 9 minus 2, and 4 times 2 by 9 plus 1. So that gives you this. So I took out the 1 by 9 outside because then it's easier for you to do the distance, because there won't be any fraction left. So you just have to find the magnitude of this vector, and then you multiply that with 1 by 9, you're going to get the distance AF. So it's 1 by 9 times root over minus 10 whole square plus minus 14 whole square plus 17 squared. This If you use your calculator, you get 3 root 65. So if you simplify this, my bad, let me use a different color. This and this cancels out. So you will have your distance, which then is root 1 by 3 root 65. That is what the question told you to prove. So I've proven that, right? The last question for this paper. It says the point C has position vector OC. The x component is 3. The y component and the z component are not known, but they are constants. Okay. OC is perpendicular to AB and angle AOC is equal to angle COB, right? So let's draw the diagram here again, right? So I have the line AB and O is a point. I do not know where it is. It's somewhere here. It could be on the line, it could be somewhere else. So let's say it's here. So now it says OC, so that's this line, the green line, and the orange line, they are perpendicular. So if they are perpendicular, if you take the direction and you find the dot product of it should be equal to 0. So what is AB vector? OB minus OA gives you 205, and OC is just this, right? So if I take the dot product of them, I'm supposed to get 0 because that's what the question says. OC is perpendicular to AB. So if you do that, 3 times 2 is 6 plus 0p plus 5q, that's equal to 0. So from there you can easily find the value of q. Q then turns out to be minus 6 by 5. So you have used this information and found the value of q. Now we're going to use this information to find the value of p, right? So it says angle AOC is equal to angle COB. So AOC, that's this angle, and COB is also this angle. So the question says that they are equal, right? So how do I find angles using vectors? Simple. Use dot product. So cos theta would be equal to OA dot OB divided by magnitude of OA, magnitude of OB. Similarly, cos theta could also be written like this: OB dot OC divided by magnitude of OC times magnitude of OB. Right? So that's what I did. So let's find the magnitude of OA. OA magnitude of OA is 3. The magnitude of OB would be equal to 6. Right? So using this, the principle that I've said, cos theta would be equal to this times or this. Right? So I could say they are equal, right? So here you have OC on both sides. I can cancel this out, but I cannot cancel it when we are doing dot product. Because if you remove the OC, you have nothing to do find the dot product of, right? And the other thing is OC is the magnitude of OC is just numbers, so we can cancel them out. So I know the value of magnitude of OA, which is 3, and the magnitude of OB is 6. So if I cross multiply, so it's magnitude of OB times OA dot OC equals magnitude of OA times OB dot OC. So if you do that, you can find the value of P, because you already know the value of Q. So what I did was 6 times this, right? Before I do that, you can cancel out the 6 and 3. So now if you find the dot product, it's 2 times 3 plus 2 times 3 minus 2 times 1 minus 1 times Q, right? I already know the value of q, which is 6 by minus 6 by 5, so I plug it in here. And here is 4 times 12 plus 2p plus 4q. I know q is 6 minus 6 by 5, so if you put it here, you can easily find the value of p, which turns out to be minus 18 by 5. So that's all for today, everyone. Best of luck with your P3 exam that's going to be held, I believe, on Friday. Thank you.